Hello friends, I am Nikam. Welcome you all on our channel eFunda for our today's topic Flow Engineering Guide, as we are starting this as a new section and that will be presented in a series, as we have already completed our one series, that is oil and gas engineering and their details. So please watch our previous oil and gas section series where we have addressed oil and gas introduction, wellhead and wellhead control panel, then basic instrumentation for offshore, then shutdown valves, motor operated valves, and then choke valves, and further down to the difference between MPFM and a test separator. As these are the details were captured very informatively in all our videos, so do visit to our channel eFunda and watch all our previous series. Now let's begin with our today's series, as this we are going to present in parts so as to capture all the details to better understand the concept related to flow engineering. After our successful series on oil and gas engineering, now we are presenting today Flow Engineering Guide, and this will be a new series. It will be presented in parts. Flow Engineering Basic Introduction, Flow Engineering Guide, Volumetric Flow Measurement, Flow Engineering Guide, Mass Flow Measurement, Flow Engineering Guide, Velocity Type Measurement. In today's topic, we are covering Flow Engineering Guide Basic Introduction. So let's continue with our today's topic. Let's begin with our today's topic, Flow Engineering Guide Basic Introduction. For understanding primary flow measurement, it is very important to know the basic of flow measurement with their properties, type of flow meter and their details. We will move on to their properties. Basically, we will see in step by step. Static properties, static pressure, the pressure exerted by fluids at rest condition. Density, one can see in a formula, density is equal to mass by volume. As everyone knows, density is a very critical, as it varies with temperature and the pressure, and the impact of heating and cooling. We will see heating causes a substance to expand, that means increasing its volume and decreasing its density. Cooling causes a substance to contract, that is decreasing its volume and increasing its density. Density of a gas can be defined by formula shown on the screen. Then density of a steam is calculated using steam table and not gas law. Density of air at a 0 degree Celsius and 1 atmospheric is equals to 1.293 kg per meter cube. This is all about the density. As you know, specific gravity is also critical. Specific gravity is a ratio comparing to the density of a fluid to the density of water or air while at the standard conditions. Moving on to next property, that is dynamic properties. Dynamic pressure is the pressure above static pressure caused by fluid movement. Now we will see fluid flow characteristic. Fluid flow can be grouped as internal or external flow. Now we will see various types of flow. Laminar flow is extremely smooth and ordered flow, one can see in a figure. Fluids that have a high viscosity generally will experience the laminar flow, where highest velocity can be found at the center of the pipe and the lowest velocity can be found at the along the pipe, where the Reynolds numbers are less than 2300. That means laminar flow is a predictable and slow mixing. Moving on to turbulent flow. Turbulent flow is disorganized compared to laminar flow. Fluid with low viscosity will experience turbulent flow, where one can see in a figure that Reynolds numbers are greater than 4000. That means turbulent flow are unpredictable and rapid mixing. Fluids flow in a laminar fashion, typically high viscosity such as oil. Moving on to transitional flow. Transitional flow is a flow exists between laminar and turbulent flow rate. One can see in a figure where the Reynolds numbers are between 2300 to 4000. That means this is a transitional and turbulent outburst. These are the various types of flow we have seen, and we will move on to our next point, that is Reynolds number. Moving on to Reynolds number denoted by Re. Flow is often measured in terms of velocity. Therefore, when a different portion of a flow are moving at different velocities, then the measurement accuracy will be affected. To understand, one can see the setup below is shown, where the glass tank supply with various instruments are kept, and there one can see the flow profile. The flow profile depends on the combination of factors, including the forces that act to keep the flow moving at a constant rate. The relationship between these forces are expressed by the Reynolds number, and it is a ratio of inertial to viscous forces specific to the flow condition. One can see in the formula that Reynolds numbers is equal to the density of the fluid flowing through a specific diameter of the file with specified velocity divided by the dynamic viscosity of the fluid, which will impact the flow moment. As this is very useful to understand the concept of various flows, that is laminar and turbulent flow, for which we have referred some of the numbers of Reynolds where the ranges are specified. This will be helpful to understand those numbers. For better understanding of flow engineering, one should understand Bernoullis principle, which will help to understand the flow measurement. The flow measurement is one of the most important industrial measuring process, where the flow measurement can be achieved for both gas and liquid. In order to understand flow measurement, we need to discuss basic of flow, which is defined by Bernoullis theorem. What Bernoullis theorem says that energy per unit volume before is equal to energy per unit volume after the restriction point. One can see the pipe where one can see the velocity at the inlet as well as the velocity at the outlet. In between there is a restriction where the velocity is increased to complete the flow with some pressure drop. As Bernoullis theorem states that energy per unit volume before is equal to energy per unit volume after, where the pressure energy plus kinetic energy per unit volume plus potential energy per unit volume is equal to the pressure energy as well as the kinetic energy per unit plus potential energy per unit volume after the restriction. Very often it is stated, or in the Bernoullis equation effect, the reduction in a pressure which occur when fluid speed is increased at the restriction point. As in our flow engineering guide basic introduction part, so far we have seen various properties related to the flow measurement and their various types and the importance of the Reynolds number. Now we are moving on to the flow measuring devices, where we, for simplicity, we have commonly categorized the type based on their operation principles. One can see in the table differential pressure, that is a head type, mass type, that is a mass flow rate measurement directly, velocity type, and open channel type, and other types of flow measuring devices. In this industry, most popular type is differential pressure type, where basically orifice plates, venturi tube, flow nozzles, elbow, pitot tube, averaging pitot tube, variable area, that is a rotameter, wedge meter, Vicon meter. These are the types are covered. Under mass flow, Coriolis and thermal. Under velocity, magnetic flow meter, ultrasonic flow meter, turbine flow meter, vortex type flow meter, and the various other types of flow meters are covered in table 4 and 5. For these details, we will have a separate session or a part where we will cover these type in detail for better understanding. In basic introduction, we are moving on to method of flow measurement, that is a volumetric flow rate and mass flow rate. Volumetric flow rate measuring volume of the substances, and mass flow rate measuring mass of the substances. One can see in the equation volumetric flow, that is Q is equals to A into V, where A is the cross sectional area of the flow meter and V is the average fluid velocity at cross section. In mass flow rate, density is multiplied by the velocity and again that multiplied with the area of the cross section. Basically, these are the two equations used primarily for the flow measurement method, and these flow measurement methods will be covered in our continuous part, which will be covered in our next series of videos. Stay tuned for those series and keep watching our channel eFunda.